Hey, welcome to AUTOMAT Live-Coding. Normally on this stream we write AUTOMAT and actually demonstrate it. AUTOMAT is a game automation app. It can mostly record macros, but it's slowly learning to do other things. Right now we are working on key pressers, or actually be more specific, we've been working on the ability to turn large objects into small objects that can still be pressed and still look nice. It's a long thread. This broke some animations which are currently in the broken state, so when I'm moving the object you can see that it's jumping. Animations are not there. We were supposed to fix animations today, but I have found better things to do. So the better thing that we will do today is we will take a look at the live presentations from a conference that happened last week, this week, and it's actually still happening. There is a workshop today evening, so if you want to attend you can still sign up. I mean, you can join, basically. It's an open conference. And the presentations that happened on live, they were very interesting. So I wanted to go through them and maybe gather some ideas. It's going to be a little bit of rambling, probably. But live was a great place. Like, I took notes throughout the whole conference and I have plenty of leads about cool ideas, papers, systems, articles. So we will have to take a look at, we will do this on stream. Maybe today, maybe another stream, but Morphic, eToys, disclosable computing, I'm not sure this is, I will have to take a look at this. Some ink and switch prototypes and Boxer. So there was one attendee who really sold Boxer quite well. I got interested in this and I want to take a look at this system more. I think I saw it. The Boxer name comes from the visual abstraction that's present in the system. Like the computation is basically represented as boxes. So, but apparently it's not just a simple one-off, visual programming system that was created, published, and forgotten. This one seems to have a little bit more ecosystem behind it. Like, there was something interesting happening there before it went away. So we will take a look at this interesting legacy. And one very valuable observation that I kind of noted during this, actually it was from one of the live presentations. It was from the sound code class, this presentation. This presentation didn't really show the music programming system that they developed. I mean, it was shown a little bit. It wasn't explained in depth. But the key takeaway from this presentation is sound code class. It was that music and the ability to play with sound, it provides this immediate feedback when you are programming, and it allows you to be creative in a way that many people would like to be, but they cannot because the music software is just not very accessible, not very easy to use. And programming, good tools for procedural music generation, they can really connect with people really nicely. They prototype this in the class, but the direction where I'm looking at this is that when you are looking at a source code of a program, like when you look at this, maybe I can open C++ because C++ is more messy. For normal people, those are hieroglyphics. Like, you look at this and you recognize some words, but what do the words do? Why there are so many parentheses and funny placed interpunction characters. When somebody from outside of programming who hasn't experienced this looks at this, they see hieroglyphics. One of the reasons for skeuomorphism in the visual design of programming systems or visual programming is that it takes away this barrier between a new person and, you know, if a new person looks at something that looks like that, it's, maybe this will not do anything interesting, but something like that, you know, you can kind of understand what's happening here. There is a timer, okay, and there is a cable going to the mouse, and from the mouse back to the timer, yeah? You can see what's happening. And this also signals to you a design of the stuff that you are seeing. It's a message to whoever is looking at it. Who is it for? Is it for you or is it for someone else? When somebody looks like this, they think, oh, it's not for me, it's for professional programmers. If you're a programmer, I think if you take a look at chemical diagrams, like stuff like this, when you look at this, is this funny molecule, vitamin B12. So when you look at things like that, you immediately understand this is for chemists, this is for people who deal with chemistry, right? It's not for me. But if the same formula was written in a programming language, you would think, oh, it's something for me, I'm a programmer, I should be able to understand it. And the graphical language acts, like visual metaphors act in the same way. They signal to whoever is looking at this, hey, this is something for me, I can play with this. Even when under the hood, this is actually super advanced, you know, low-level programming, it still looks like it's like this is assembly. This is not even assembly. This is machine code. This is level below assembly. But it is packaged in a way which makes it familiar and friendly. And to me, music, this point about music serves the same role. If you can make music in something, it's very easy to think of this as something less foreign. Like, hey, I can very quickly create a couple of notes and it can play some melody or some beat, some repeating sound pattern. So music would be a nice thing to embed in AUTOMAT. It goes slightly against our objective of automating games, so we are probably not going to explore this, but it is definitely something to keep in mind. A different visual programming system that wasn't focused on games would totally approach, fancy music generation. There are a lot of music generation environments which are visual. They are a little less, I would say, threatening, like more alien. Like, I think this is the term that we decided is the best. Yeah, music breaks barriers, and it's a nice thing. It would be nice if we had some objects within AUTOMAT for working with music, but maybe someday, who knows. Very powerful idea, and this is why I like that presentation. Right. So there have been more presentations, so let me go over those topics, and maybe for each one of them I will try to summarize some key points that were most interesting. So there was this, let's maybe go in order. There was this presentation about language-based dependency tracking, which I think so it's about inverting computation, essentially. This presentation and another one there was one more spine. I think they both approached the same problem, possibly even the solution was very similar there. Although Spine had some nice tricks that allowed it to distribute, because when you're modeling computation, in time, you create sort of a data flow. And then when you want to change some output, you have to walk back through this data flow. There are a couple different approaches to this. The approach used by Spine had this nice thing where it could decide which, I think by default it always pushed the changes towards the first branch, but it had a means to actually control this. So you could say that I want the changes to be distributed equally between the two branches. And they were both connected to the visual pattern, so the visual canvas. So you could literally grab stuff on screen, move them, and that was causing changes. Okay, maybe in this one it wasn't quite causing changes in the code, it was just highlighting where the changes come from. Spine I was asking the authors, so the reason the être for Spine is that it exists to solve some frustrations related to programming. So it aims to be to make programming more interactive, more easy to tweak. The language-based dependency tracking, the objective here was to create visual essays, visual data explanations. This data flow backpropagation, there is a little bit of this in AUTOMAT. There are some objects within AUTOMAT that can be evaluated from multiple directions. They are kind of hidden, they are disabled, but there are some tests in the code base that verify that they are working. They are just not wrapped in any visual design. Oh, you cannot really interact with them. If you look at the source code, the library.cc, you can find them there. The approach that AUTOMAT uses is a little bit more narrow. AUTOMAT's approach is limited to simple formulas. So if you have, for example, x squared plus x equals something, you are not able to backflow through this. But I think this also applies to Spine probably, because Spine picks one of the branches as the preferred one. Anyway, so AUTOMAT is limited to simple formulas, and AUTOMAT, I think it's actually very similar to Spine, the way we do this backpropagation. We also have this, I think, distribution of change. Not sure. No. I remember. Our approach is totally different from all of those. So the way AUTOMAT does it is it creates a formula, like an expression for calculating something.
Knight says,
Hey everyone.
Hey, Knight. So Spine does this backpropagation where it goes step by step and pushes the change. The prototype that's embedded in the library.cc uses a symbolic approach. So if you have a formula, for example, for Celsius to Fahrenheit, yeah, with a formula that looks something like that. So AUTOMAT has a tiny symbolic transformation engine. It's something that can basically take this formula and we can ask it, okay, what's the formula for C? So it decides, hey, the formula for C is F minus 32 times 5 by 9. And what it does is it takes the expression, it finds all of the variables, it locates them, and it attaches observers to each of those variables so that when Fahrenheit changes, it will use this formula to update Celsius. So AUTOMAT uses symbolic transforms and attaches observable handlers whenever something changes. When I was going through this backpropagation, this topic of propagating changes, the one thing that would probably be more general would be to use a proper differentiation library. It has some issues. Automatic differentiation is slower. It's just like this symbolic approach is instant. Yeah, when you have a formula for how something should behave, when you change something, we have derived formula. We can basically update the output immediately. As you are dragging something on screen, the output changes, in real time. The problem is that we can do symbolic transforms only for rather simple formulas. If this graph of relations between symbols is more complex, especially if it contains cycles, this whole approach suddenly becomes much more complex. Automatic differentiation can work with however complex formula you want. It can even work with discrete if conditions, if branches. But the process of finding solution is an iterative process which has multiple steps, and you have a lot of different heuristics for how to find the solution. Like even once you have a gradient, you need to figure out how you want to use the gradient. You need to select an optimizer. Stuff like Rangakuta, Adam, or simple gradient descent. Yeah. During the question session, the organizer of the conference also asked one question which was very interesting. He asked about... Oh, sorry, no. That was Jonathan Edwards, one of the most experienced researchers that attended the conference. He asked about handling of if conditions. Because if you have a program that looks like that, for example, if then you want to print A, and you want to play with the A, yeah? Let's say A is equal to 2, because the random value resulted in 2. So if you want to grab it and switch it to 1, it is assigned to a constant here, right? So there is no way to change a constant, but maybe this condition, this expression used in the if condition could be changed instead. Maybe this backflow propagator would actually look at the expression used in the if and realize that, hey, maybe there is something I can do here to switch to this other branch. But this is a very hard problem. This would require some kind of symbolic execution of both branches and some also kind of time reasoning on this backflow propagator. It's probably doable, but requires a lot of effort, a lot of research, and it will be super complex even if implemented. Still, it's a nice idea. So that was one kind of topic on this presentation. Data flow backpropagation. And before I move to the next topic, I would like to switch to my background project that I'm playing with. I can give like a word about this. It's not related to AUTOMAT, it's just something I was playing with in the free time. Still a little bit related to AUTOMAT though, but related in a very interesting way. So, I started playing with the idea of making a handheld keyboard. Change of topic, sorry. So I made this small device, which, by the way, didn't require any 3D printing. I found a really amazing hack for making small prototypes. The trick is to use the modeling clay, polymer clay. So this black material here, this was made out of clay. And then I put it in the oven, and together with the electronics, except the battery, don't put the battery in the oven, I put the whole basically development board with all of the keys, switches, wrapped in the modeling clay in the oven, baked it for half an hour, and it came out with this nice, like really solid plastic. It's very hard. I would say it's probably as tough as ABS. Anyway, so this is a keyboard. It has keys in the top part. I can switch the camera maybe to this one. Oh yeah. It has 3 keys. Key 1, 2, 3 for the thumb, for the index finger, key 1, key 2, for the middle finger 1, 2, for the ring finger 1, 2, and for the pinky. The pinky is used for shift. And I can type of this by pressing keys. For example, this is I, E, this is D, and I have plenty of, like this is space, backspace. It's a custom keyboard, essentially. But since this is a custom keyboard, now I am trying to find it's going to use an ad hoc keyboard layout anyway. I looked at some prior art in keyboard layouts. There was this Penty, some others, but I decided, like, this is actually a very nice design. Like, it looks very scrappy, but this is actually one of the most ergonomic ways to build this mouse. And look, he even used proper keycaps. It's a very subtle thing, but different sizes of keycaps, they actually make sense. Your pinky, you don't want to twist it so much, so a bigger keycap actually helps with key presses. And those are very nice mechanical switches here, so it's also nice to use. Anyway, there are no keyboard layouts for custom keyboards with, different numbers of keys for each finger. So some people came up with their own keyboard layouts. There are some steno keyboard layouts. I'm not using that. They are usually two-handed. I have a one-handed keyboard layout. So I wrote a piece of software, like the firmware for this keyboard, which connects to my phone. And right now I'm optimizing the keyboard layout so that it's maybe more efficient. So in the background, the stuff that's happening here is the optimizer that tries to find the best positions for different keys. And it's running happily. And I see it is assigning some keys already. Yeah, and the optimizer is here. And you can see it optimizes the effort of typing the text. I collected a bunch of texts and it's calculating how long it would take me to type all of those texts. It looks at movement of fingers, it looks at the effort related to press each individual finger and finds this optimum value. Now I am actually looking at what it found. Okay, it looks like L is assigned to this 0, 1, 1, 1. It's actually a very nice assignment. Okay, and L has also small probability of appearing on other places. So I will tell you a little bit more about this algorithm, but first I will record L. So essentially, what it is doing here is it is something called ant colony optimization. Many people, when they want to optimize something, they immediately reach out for evolutionary algorithms. Because this is probably what Wikipedia says, or what some online courses say, or maybe what is being taught at some universities. This is a bad idea. Evolutionary algorithms, they work, but they are like the most basic meta-heuristic, except maybe simulated link or just random search that you can go for. There are much better, kind of clever, smart algorithms that can do combinatorial optimization. One of them is a technique, like a broad technique called ant colony optimization. It's usually shown with, with ants. But it can be applied to any problem, basically, as long as it involves step-by-step construction of the problem. So what you do in ant colony optimization is you create a big table which you call pheromone matrix. It contains pheromones, and those pheromones, they are used by picking a new solution. So when you want to pick a new solution, you look at the pheromone matrix and you randomly pick a new solution using pheromone to influence your choice. And when you have a pheromone matrix, usually you start with just zeros everywhere. Not zeros, ones. Like, it's full of pheromones. So it basically randomly generates just random solutions. Nothing crazy. But then what you do is, after you generated, let's say, 100 solutions, you look at them and you evaluate them. And you pick the best one So out of all of the solutions that you evaluated, you pick the best one and you deposit some extra pheromone into the matrix, into the pheromone table that matches the solution, the best solution. And then to make it numerically stable, you have to evaporate a little bit of pheromone from all fields. And you repeat this process, and you repeat this over and over and over. And it has very nice properties. It can perform global scan over the whole space of possibilities. And at the same time, notice very local patterns. Yeah, so it's just a very nice, very fast optimization approach. And if you code it properly, like if you use C++, and if you avoid dynamic memory allocation, it is just ridiculously fast. It's just... First of all, it's mathematically more efficient than evolutionary algorithms, and then it can be implemented in a more efficient way in software. And it also has a nicer visual feedback. So as you're looking at the program that's running, this optimization, I can literally look at the positions and I can realize that, hey, this key combination, 0, 1, 1, 1, is only assigned to a single key. And this key contains, maybe it contains like one another alternative, but this is the most, like the best key assignment for this character. So you can basically just use the best layout that you found, and it's good, you can just go with it. But what I'm doing here is I am running it multiple times, and each time I am picking a piece of this resulting layout that I like, and I move it into my solution so that the next attempt will be able to arrange other keys in a more efficient way, like knowing that this key should be there. So the global search, when I'm restarting the algorithm multiple times, is able to better pick up on the, incremental layout that I'm constructing here. And it was running for some time. It found decent layouts, actually the best layouts I have seen. So it's doing very well. But I will now let it restart because I like this assignment of L20111. I like this assignment because I'm typing Polish from time to time, and this will allow me to type like Polish characters more easily. Okay, let's restart. Yeah. There it is. And you can see it's evaporating this pheromone very, very slowly. And each time it's generating 100 totally garbage layouts. Like right now they are totally garbage, but they are getting better. Yeah. And L should be assigned to my nice combination. Sweet. Okay. That was a digression. Oh, but I mentioned this is something that should be part of AUTOMAT. There is a whole category of games which are based on this idea of optimization. And hard for me to think of an example right now. There are games where you have to optimize something. And I think if within AUTOMAT there were some tools for expressing this optimization process, good tools for optimizing stuff, essentially, I think AUTOMAT could be a really nice tool to play those kinds of games. This ant colony optimization is... I optimized it a lot but it's evaluating each layout on a lot of text files. So this is why it's taking so long. So each keyboard layout is optimized on all of the AUTOMAT source code and all of my private bash history, the texts that I wrote. It's not optimizing for the English layout, it's optimizing for what I write. A very personal keyboard layout. So within AUTOMAT, it would be nice if we had primitives for doing optimization to play those optimization-related games. Yeah, one example of where ant-colony optimization can be used is for routing speedruns. Yeah, this is a nice example. When you have a speedrun and you have a map with a bunch of points that you want to visit, this problem of visiting all of those points on the map and going back is like just visiting all of the points without going back. This is known as the... what's the name? Commis Voyageur? Traveling salesman problem. Yeah, this is called traveling salesman problem. And the solution to traveling salesman problem is exponential. If you want to solve it properly, the complexity grows exponentially. So it just cannot be solved optimally for large and complex problems. But ant-colony optimization is an optimization algorithm that actually can find solution and is not exponential. It is a randomized algorithm, and it doesn't guarantee that it will find the best one. It's just a stochastic optimizer, but it performs very well. It's one of the best ways of solving practically the traveling salesman problem. Okay, so something like this, something for doing optimization in AUTOMAT, that would be very fun. And something that doesn't require... I mean, of course, I can implement everything in C++ and I can just have a C++ widget in AUTOMAT that will let me do this. But what I'm thinking of is more native way of displaying this matrix, of playing with this matrix, seeing how it evolves, picking the parameters, you know, the evaporation rates and deposit from on deposit rates. You basically need C++ or machine code to evaluate a solution. You pretty much need machine code or C++ to even sample a solution, but in between the storage of this matrix, I think it would be really cool if we had something visual for this. Yeah, I think mixing C++ with the ability to see live what's in memory, this is going to be a killer feature. And yeah, it's coming next year. Okay, let's go back to life. Scrappy, oh, I love Scrappy. I absolutely love this presentation. I will tell you more about it. I will first make some tea because my throat is going sore. Okay. Scrappy. If you look at Scrappy, the one thing that it reminds you of immediately is Visual Basic. If I find the demo section, you literally grab fields, like things from the left, you pull them on the canvas, and you specify parameters in the inspector. And similarly to Visual Basic, which had this ability to double-click on a button and assign the on-click action, Scrappy has the ability to type JavaScript inline within the... basically within the... I think it has handlers, or maybe you can type JavaScript in the properties as well. It also features a central server that can synchronize the state of this application, because it's a web application, across multiple browsers. So it is just crazy to think what you could do if a Visual Basic application could be running and could be automatically synchronized on multiple machines around the globe. Yeah, it's using some clever synchronization algorithms to do this. The clever synchronization algorithms, they definitely have some limitations. Yeah, there is only so much you can do automatically, but still, it's so nice. It reduces the barrier to create apps a lot, and the apps that you create like that are very easy to use. So it not only reduces the barriers to create apps, but also to share them with others. This is a big one. So one thing I was kind of sad to learn on this conference was that Scrappy is not actively developed. It was created and then shelved because there's probably not enough interest from people around. But I mean, come on. It's so not only technology is so nice, but also the philosophy behind Scrappy. So they also have this idea that programming is a little bit too professionalized, and it's intimidating for kind of new people or people who could create simple apps for themselves. Right now, if you want to create a small app for yourself to solve a specific problem, a normal person would probably do this in Excel. Yeah, you can calculate stuff easily. Excel is something that you can play with, and normal person is not intimidated by it, even though it looks like a professional table tool. Maybe it's more intimidating now than it used to be. There is also HyperCard. I personally never used HyperCard, so I can't really comment on that. So in the presentation, but also in other materials that I've read about Scrappy, I really like the language that they use when talking about programming. They say that Scrappy is for making disposable apps for you and your friends. It's not meant for... oh yeah, this. It's not meant for stuff that's professional, robust, super efficient. It doesn't require knowing the theory behind programming. Like programming could be used for doing small, simple things. Like if you want to play a game with your friends, you can very quickly, very easily prototype a game. Like even during a party, like literally. You are on the party, you want to play Mafia or whatever, you can make like a small toy app that will help you, for example, do a timer or do some kind of tool for voting digitally, this kind of stuff. Scrappy is very good at this, and this is a very underserved group of users. And this is a group of users that... the biggest problem with this group of users is that they do not know what they are missing out. So the biggest challenge is reaching them. Yeah, so any visual app that actually aims to target this group of user, it needs a really nice kind of backdoor kind of to their lives. Spreadsheets, Excel, it's used for doing simple math. It was being taught in school even, so many people know Excel anyway. So this is how Excel got on everybody's computer. Scrappy, because it's a web app, I think maybe it's not such a big problem, but if Scrappy was installed, if it was a desktop application, it would definitely need a very concrete problem that it solves to motivate people to install it. I mean, people call this MVP or some small problem that it solves that people cannot solve right now, or that is just not solved as well. I may be biased, but for me games are an area like that. Like for AUTOMAT definitely, but whenever I think about this problem, I tend to come up with other game-related projects. Maybe not necessarily game automation, but like utilities for playing games, even. I think they could be made with this. Like, I'm also thinking about role-playing games, right? They are not computer games, tabletop games. In those games, you have to keep track of the character card, you have to keep track of statistics, you have to roll. When you play the game, you have to roll the dice according to the stats of your character. And there is a lot of math that could be automated, by the players, essentially. Yep. Scrappy is a very cool project. I think it's somewhere online, the materials about Scrappy, so it probably can be checked out. Let me see, what do I have here? Oh god, what is happening? 010, what to... I don't like that very much, but... I'm looking at my keyboard layout now. Yeah, maybe it's not such a bad idea. I will let it optimize a little bit more so that it falls below 120. You can see that it's finding good layouts in much fewer iterations now, because I hard-coded some of the key locations for it. It's able to do this global search a little bit more efficiently. N. I really like N at this position. I'll give it more time. Okay, so that was Scrappy. Then, okay, we go to, I think that was Hyperclay. That's the name of this project. And was this? There was Scrappy was Visual Basic. I think a little bit more polish in the interface of Scrappy would take it a long way ahead. Now, in the demo, yeah, the fact that everything is represented as basically black boxes with text. This could be so much more visually interesting. It's, yeah. The interface could absolutely bring it up to like a next level. This is already good enough. It just needs a slightly better interface. Inspector maybe could be a little bit more contextual rather than in a, I don't know, sidebar. The fun thing, the demo actually showed that you can actually use the like sub-machines, sub-components within Scrappy to perform sort of a permission system even. So that was really a nice thing. Okay, I wanted to go to Hyperclay and actually let's check. Yeah, this is it. There was one more topic which was I would say it was similar in some way, the wobble web. The idea with both of them is that a complete application can be encoded into essentially a single HTML file. Wobble Web did this in a fairly visually kind of attractive, reactive way. You would edit the web page. It looks like it's more for kind of interactive demos, maybe some algorithming. And Hyperclay is a little bit more app-focused, I would say. So the idea with both of those projects is that HTML file, if you serialize the state of JavaScript into HTML, it can be used as a sort of persistent mechanism for web pages, like persistence mechanism for web pages. You can develop them interactively, and maybe even the last one, the REPL-driven development. The one thing that I took out from this last presentation on REPL-driven development is more of how many issues JavaScript still has, even though it feels like JavaScript should be super REPL language. Yeah, we have this developer console. There are still a lot of rough spots, like especially importing of modules. Maybe that was slightly presentation. Slightly different topic. So the unique thing about Hyperclay is that it has the ability to have like admin interface for web pages that somebody can edit and other people can view them. And Hyperclay, I think, is a SaaS. I haven't seen this explanation, but it looks cool. Okay, let's go through this. Okay, I built several dozen websites a year. Yeah. When I'm in a flow, coding a website feels like writing a story. It's better than a story because I can interact with it as I'm coding. Okay, I'm not going to read this aloud. Yeah, so websites are these kind of like static functions that once written you can play on them and they can do stuff. And it's rather easy to host a static web page, like a web page as a tool. When you, so those are examples of web apps that can be hosted as a single static apps. Super simply, almost everywhere. Yeah. That's true. They have an issue that you cannot introduce persistent changes to those static websites. I mean, theoretically, HTTP has those verbs called put that are meant for data upload. So theoretically, HTTP supports this, but probably no servers really allow this to be used. It would be nice if there was a way to have more state in static web page. So you can have state, but it's only local. It's very hard to share this state with other people. For that you need central server which will accept data uploads. Yeah. That's true. I really like the way that this is written, because it's written in such a way that you can interpret it not only in relation to websites, but also to other objects, like programs, like native programs in computer memory. They have kind of the same problem that when you do the computation, it's all thrown away at the end. The persistence is hard. You need to really work hard to make stuff persistent. Either write them to files or map files into memory in a very specific mode, which is tricky and very few people know how to do it. Yeah, and even the stuff that I'm doing here with optimization of keyboard layout, it could benefit from better persistence. Yeah. Nice. I wonder where is the tangerine idea from. It looks nice. But it's a really nice branding. Very consistent. True. I'm not sure if I'm not making this up, but I think, if I remember correctly, that the Opera browser There was a time in history where Opera browser included a built-in web server. Yes. And the crazy thing was that the server was actually running locally. It was doing the NAT piercing through some of the Opera's infrastructure. So every user of a web browser could host a website on their own machine. The problem was that the website was only active when your machine was on. But that was a crazy feature. Totally could exist now, yeah. Yeah, just a interesting thing why it doesn't exist anymore. Maybe the costs for the central NAT, those STAN servers, maybe they were too high. Yeah, so reinventing the persistence layer is frustrating. Yeah. Yeah, interesting. So a blog. How would you make a blog using Hyperclay? Yeah, the storytelling is A+ here on this webpage. Really nice. Yeah. Yeah, it really simplifies also the middleware processing. So you don't have to... If you store the state directly in HTML in the DOM, you can translate between HTML and DOM and vice versa. Yeah. Regular apps, they do this rather complex flow where they scan DOM, they take data, send it as JSON to the server. The server stores it somewhere in the database using different schema probably, reads it back, and renders it in a template. It saves a lot. The idea of HTML being an interface to the app is also the key idea of the test. Representational state transfer. The idea is that instead of transferring the JSON, you are transferring the representation of the state, which is HTML. And this representation of the state can then be used both by people, or by agents, or by software running on another machine. in those changes persist, I would add this asterisk that changes persist globally, because change persistence is using local storage. It's not that hard, right? But global change persistence, it should be as easy as local storage. So hyperclay internally, it uses this strip restore process to hide the editing interface. Nice attribute, persist. So this is how the admin interface looks when it's enabled. You get access to, I guess, those gear icons. Yeah. The thing about hyperclay is that it's hosted. The idea with Wobble Web is that it generates HTML, like local HTML. And they seem to be targeting slightly different problems. Okay, that was hyperclay. I like the... obviously. I wish we had something like this as a standard way. Like web servers should just support something like this. It should be just Nginx should have a default, something like that. I guess authentication or authorization is a problem. Wobble Web, nice thing that it does is that it uses CSS transforms for all elements. So everything on screen can be moved very easily, very fast, it's very responsive. Everything is, I'm guessing, positioned using the absolute layout, except maybe this video feed, which is fixed. And the objects can be scripted. Yeah, that's it. basically Wobble Web. You have this web page and you can edit it inline and you can save it when you want to save it. Fun place for playing with code. Let's go over their things. Yeah. So this presentation, live programming in hostile territory, it touched a super important problem of interoperability and what we unfortunately have to deal with, adversarial interoperability. It's a concept as old as piracy, essentially, as software DRMs. There is a lot of software, especially commercial software, that really tries to guard its data very well, and it tries to prevent any other apps from accessing the data. There is software that tries to, again, it is all because of this commercial motivation in software. which tries to achieve a sort of they call it domination. I'm looking for a better word, but I think domination is actually pretty good. It sounds weird, but the idea is that almost any language, or not only language, any ecosystem is probably... There are economies of scale that help software systems. So getting rid of your competition and making users switch to your solutions helps basically each software system. So this presentation offered a glimmer of hope in this kind of sad state of things. It offered 3 strategies that software today can use to get out of this perverse incentive to dominate other software types. So this is meant for new projects or new programs that aim to not repeat the mistakes of other systems which, unfortunately, they have to play the game. So they are proposing 3 strategies that the rules of this game can be attacked at their foundations. They call them adversarial. Sorry, not adversarial. They call it just addressing. Or maybe adversarial. Addressing, embedding, and there was one more. Extending? Oh yeah, extension. The idea is that the system that you're creating, it should offer a way to address stuff within your system. The one nice example that they give was that they can actually use the accessibility APIs. But even the accessibility APIs, or like in DOM you have CSS selectors that can also be used like that. There are applications which are motivated to not expose this, or like to even obfuscate this. On YouTube, for instance, if you look at the source code of the YouTube webpage, you will see that all of the identifiers are obfuscated, randomized, and it's very hard to manipulate the DOM. The other strategy was embedding other applications, and they also had really nice examples where spreadsheet essentially was embedded and visualized graphically. Yeah, that was, I think, data flow between cells. And the extension, the last strategy, was meant for the least cooperative apps. Yeah, maybe this is the one that used accessibility trees. Yeah. Another cool example that exploits the stuff that you can get out of the apps using the operating system APIs. This is important, especially for AUTOMAT, because games largely do not want to be automated. Kind of the point of the game, when game developer writes a game, is for people to play it. And all of the nasty mechanisms that are in there that are wasting player time are meant to be wasting human time, not computer time. So the games often employ a lot of protections to like force the users to sit through the gacha games and to motivate the users to, you know, buy the in-app payments or whatever. So there are some mechanisms that game developers employ to prevent automation. Not only game developers, I guess it also applies to many online services, which they like to protect their data to prevent competitors, for example, from replicating the same website with the same data but with a better interface. I really love the idea of adversarial interoperability, also because this is the area where I kind of worked professionally for bot detection. So on Android in the network, this is the area probably where I have the most experience. It is a very sensitive topic. The problem with this topic is that talking about it makes the tools for, you know, online abuse makes it easier to create those tools. And there is no technical way to distinguish ethical use of, you know, those tools from unethical one. So it's probably better not to share them too widely in general. Okay, that was live programming in hostile territory. Okay, I want to talk more about this. So there is another thing here, it's that it was maybe presented in the context of web apps or system APIs. If you go to the lower level, if you attach to another process on the, you know, machine code level, when you have the same memory as another process mapped, you can scan the memory, modify it. It opens up so many fun possibilities of hooking, patching, controlling other apps, other games. So it's also very interesting on the machine code level. Maybe machine code is a wrong name, memory. We are definitely going in this way. We need a way to patch memory of other processes if we want to play games. We need to kind of read the state of the game. We will need those kind of tools. Accessibility APIs are, from the point of view of what we are trying to do, accessibility APIs are very nice. Official API. The stuff that we are going to do is not going to be using any official APIs. Because internally the games don't offer those nice accessibility trees. The games are a jungle of pointers and memory allocation and deallocations popping constantly. So we need slightly different tools to hook into games in a robust fashion. We will get to this. Okay, Wobble Web. We have sound code class. Okay, this is the one that I started with. But the biggest takeaway, the one that I liked the most in this presentation, was that the ability to play with sound, it breaks the barriers that people have for programming. fine, I covered it. There is AUTOMAT. I'm sure you're familiar with AUTOMAT. If you're not, you can watch this presentation. I tried to post a link in the comments to the full article. It hasn't appeared. There is probably maybe moderation, but there is an article that comes with this presentation, so I will try to get this on the video description. Yeah, the thing in this article is that the core idea of AUTOMAT is not to create a tool for children. It's a tool for professionals. It just aims to encode the abstract primitives that we professionals have in our heads in a better designed visual tools. Yeah, if I had to summarize the article that comes with AUTOMAT presentation, it's that let's design programming abstractions in a humane way. AUTOMAT is doing mostly automation, but even the tools within AUTOMAT that are doing those macros, they already use this idea of composable abstractions. They are toys that can be, combined together. If you are programming a lot, if you are programming, for example, the piece bus problems, or I'm not sure, lead code, yeah, lead code, this is what it's called. Those lead code problems are actually not that hard once you realize that they just use a couple different techniques that are very little known, and it just takes time to learn them. And with a proper design, we could take those advanced, sophisticated algorithms like ant colony optimization. We could take this ant colony optimization and turn it into something that a baby could use. It's like giving fire to a baby. Advanced complex things can be packaged in really nice interfaces, visually appealing, quick to understand, more usable by experts, and those nicely designed interfaces could be used by anybody, like both new people, experienced people, everyone. And this is the point of the article. And the one thing that I think is a big problem in the world of programming is the formalism. When you think of an abstract concept, programming languages, they have this way of trapping your mind and forcing you to think of an abstraction in terms of very specific things that the language exposes to you. Like object-oriented design, where you are thinking about something and you want to model it as a set of interacting objects, like not objects, as a set of classes with inheritance, encapsulation methods, and protocols, APIs that they use between themselves. Invariants, APIs. The same goes for functional programming. In functional programming, you need to express everything as functions, trapping side effects into some kind of effector monads being passed around. And really, what you should be thinking is not in terms of those programming primitives that are there, but in terms of in terms of a couple design objectives. Like how easy it is for somebody to understand what they are looking at. You know, if you're designing a component in a program, this is what you should probably think about. Like when somebody takes a look at this component, can they immediately understand what it does, how much data does it store, how it is used. How quickly can you recall an element? How quickly can you learn the element? Are you kind of scared by looking at this element? Do you want to take a look inside or not? Is it easy to compose with other elements? If you're a programmer and you're designing the system, you can try to think about mental transformations that you can perform with some concept. If you're thinking about a graph, like what this graph in your head, can it evolve into other things? Can it evolve into other things, or did it came from other things? What operations can you perform of it in your head? And once you think all those things, you can start to design it in a way that's easy to understand at a glance, discoverable, memorable, fast to use, and then faithful to the abstraction in your head. I would say this faithfulness is maybe the least important of all of them, honestly. Because this is more like elegance, like feeling nice about your solution, and what really matters are the first four. That was also easy to master. Okay. That was an automat. Let's go on. AMP sheets. AMP sheets really remind me of these good old ideas in visual programming from 2000s, where there have been plenty of systems that tried to extend programming in some way. AMP sheets don't extend programming, AMP sheets extend spreadsheets with a new capability. I haven't read the full paper because this presentation also comes with a paper that I still have to read. And so what they are showing is one of the approaches that spreadsheets can be extended with multiple values per cell. There are other approaches that they prototype with like stochastic re-execution of spreadsheets also. It's a cool idea. It's a cool idea. One thing that always seemed strange to me was that in spreadsheets, within a single spreadsheet, you often put several tables next to each other. And it feels so strange to me because when you put a table within a spreadsheet, to me it feels like, hey, this car text, this is a label for a row, right? And this label should probably live, in the sidebar, instead of having this one enormous spreadsheet which can be a place where you put 10 different tables and they work together. Shouldn't we actually have like 10 separate tiny spreadsheets? Like, spreadsheet could be like this could be the height of the spreadsheet, or even this. And there could be multiple tables kind of scattered around. And the separation of a spreadsheet into multiple tables means that the axes, because a table has two axes, x and y, rows and columns, means that they are independent and that their interpretation should be a cross product of all of the values into tables. So yeah, there is this notion of independence that is, I think, very important and that can be actually encapsulated in AMP sheets. So in AMP sheets, when you are putting multiple values in each cell, what you are really saying is that they are independent and you are interested in a combinatorial combination of all of the combinations of the all values. It's something that's missing from simple spreadsheets. This is something that you can probably express in Excel, honestly. Excel has a lot of tools, so it can probably express cross products. I'm 100% sure about that. But I think the AMP sheets solution is nicer. It's more visually clear what's happening. You are not using some obscure functions. And yeah, where I would probably go if I would try to model tables within AUTOMAT is I would try to model independent options as separate tables. So I would have a table of cars here, essentially, and when doing this sort of example, I would have a table of cars with just two values, car A, car B, table of two apartments, apartment A, apartment B, and then another table which computes total that takes all values for cars, all values for apartments. Because when you split them into separate tables, you mean that they are independent. You're interested in combinations. But yeah, I still have to read the whole paper. It's definitely, this is probably the most proper paper on this conference, with well-structured, goal and methods, and yeah, this is like the most scientific probably paper on this whole conference. Oh, but maybe I was a little bit too soon, because there is this other one about pattern matching. This also looks like a proper scientific paper. Like most of those, they were more like reports on different visual programming systems, honestly, or reports of systems being applied somewhere. And those two, they were like papers from the actual, they had more sciencey feel to them, definitely. That one of debugging pattern matching conditionals, it reminded me of also of very old school visual programming science. It showed several ways of providing visual feedback intertwined with the programming language. Pattern matching. I was looking at the program, it looked a little bit like Rust, but it wasn't quite Rust. I think because Rust would have more all those ownership annotations, right? Anyway, language is readable. Yeah. So this is how the annotations looked like. It's a fun thing. In the past, in the very old days, it was common to extend some development environment and to actually implement this kind of thing. Like Eclipse had a lot of plugins like that. Scientific origin. I wonder where this will actually end up being used. The language that happened to be the target of their research is definitely going to receive a boost because of this research. Personally, I'm not in the business of this kind of feedback because I feel like a better strategy for providing feedback would be to make programs a little bit more visual, a little more... Because when you're working in the source code, you are not working with the actual program. The actual program is something else. Compiler compiles this source code into another representation which is executed, and showing those annotations is a little bit like a game of trying to backpropagate results of your program back through this compilation cycle, back into the source code, back into the editor, into widgets on screen. So there is a lot of kind of chaining, of backpropagation of information here. And I think this is probably not the right solution to the problem of tangible, of like understandable programming. I think understandable programming would require moving us closer to what's being executed by the CPU. Maybe getting rid of the compiler, getting rid of the editor, and letting us work directly closer to the what CPU executes. Dynamic virtual machines, dynamic languages like Python or JavaScript, I think they offer better environment for this kind of stuff being done live. Yeah, but if this gets turned into a plugin for VS Code, I am going to use that. Absolutely. Okay. There was a REPL-driven development. I may say a couple of words about this. This presentation was really more of a report of a developer who worked in the REPL style for many years, and he shared some of his techniques that he's using to bypass some issues that JavaScript has related to this. It wasn't a demonstration of any tool, any live programming system. It was more showing how JavaScript can be used this way. And obviously JavaScript has these developer tools, but the developer tools and the built-in JavaScript editor that Chrome contains, they are not really REPL-y. And even in JavaScript, like when you want to design a program using REPL, one thing that you sometimes do is you first write a function, which is like the top level function that breaks the problem down into sub-problems, and then you interactively implement the solutions for these sub-problems. I haven't seen this one, and this flow of like top-down development, like interactive development, is something that I associate with REPL. What's missing from here? But this is probably because just JavaScript is very, it doesn't work in this way. And the last one, or second to last, was Nova. Nova is an example of a rule-based system, which is magically simple, and it uses the idea of stacks to implement some things that are hard to implement in most rule-based programming systems. I don't know the syntax of Nova fully, because that was, I think, skimmed. I think this may be an explanation of the syntax. I didn't get it. I don't know quite what's the meaning of colons or vertical bars, or the @ symbol is used in some places, or the dollar symbol. So I don't know all this, but one thing that this presentation really showed me is that even though I don't fully know the syntax, the programs and this paradigm of pattern matching, it's really simple, it's really intuitive. I think there could be the syntax of Nova is very minimal, right? I think it's probably language agnostic, actually. By language agnostic, I mean you can probably write Nova programs in Chinese or in like, any language, any natural language. Because the idea of pattern matching is so general. Yeah, patterns are a nice primitive. Yeah, I think this is something that could be very easily understood by non-programmers. Discussion around Nova was interesting. However, I only used rule-based systems. I only used Prolog at university, so I'm not an expert in rule-based systems. So a lot of the questions touched nuances of the rule-based systems, like the priority. And Nova handles priority and control flow, like ifs and loops. This is what I got, that Nova uses stacks to handle those, to solve those problems. Yeah, I cannot really tell much about those last ones. Also because it was kind of late at my time zone, and when those presentations were happening, I was practically falling asleep. Because of the time, not because the presentations were boring. They absolutely were not. Anyway, all the presentations from the live conference are on the live prog workshop. This is the name of the channel. So you can find them here. think this was maybe the first actually. It was presented. Anyway. Okay. In addition to all of those systems, the discussions around them were source of many interesting leads that we are going to explore, probably during future live streams, especially so Jonathan Edwards, one of the people who attended and one of the reviewers on the conference, he created a long chain of programming experiments that we will definitely be taking a look at. Yeah, from the get-go, those are super relevant things we should be familiar with. Oh, and my keyboard layout looks pretty decent now. Okay. I want to look at some keys. I want to look at C. It's not looking great. Or maybe it is 100. Is it the top assignment? C 100, yeah. So let's assign C to 100. Yeah, basically the program pretty much found like some incredibly good keyboard layouts already. It's still fine-tuning them, so it's still finding better and better ones. It's iteration 3000. Yeah, it keeps finding better layouts. One just now, another one. I want to assign a couple letters right now. So that I can map the Polish characters convenient places. And where is N? 0110, okay. We'll finish the keyboard layout, or at least assign a couple more characters. And after that, we will probably even code AUTOMAT a little bit. I want to bring the animations back. I want the objects to move again. Okay, so that was C. O, I'm also interested in O. Zero 10, this is the best assignment. It's good. I like it. And Z, the hardest one. Z is a very rare character in the English language. 002 isn't looking that bad. Let's see what the table says. Yeah, 002. and this one is more common. And where is V? Okay, okay. All these special effects. I wanted to assign them in a consistent way. O and L. Sure. Okay, this is quite a few characters assigned. I can restart the optimization. They're slowly finding their places. From the start, the layouts are decent. Actually, initially, the layouts had cost of something like 190 before I started assigning some keys. Now, even when we start the optimization process, it's already good enough. this optimizer program. I wrote this with Cloud, and it is getting better. It kept making mistakes, but those were small mistakes, and they were kind of obvious. Like, I could look at the source code, and it was fairly clear to me that was the problem. And when I told it to fix something, that fixes were good. The craziest thing that it did is at the end, I asked it to parallelize the evaluation, and it found a way to parallelize it with just a couple lines of code using this multi-processing pool. You can use this pool.imap. I didn't knew this API. Yeah. IMAP unordered. And the visualization to display the pheromone table. It knows how to work with the terminal graphics quite well. Oh no, there is a collision between those two. No. No, this is wrong. This is all wrong. Okay, this is taken. This is taken. This is taken. This is taken. only thing I can do. And I have to restart the search. Okay, so this optimization is running. And while it's running, you can switch to AUTOMAT. Let me fire up. I know my CPU is pretty busy optimizing ant colonies. Maybe we can do some development. And a lot of change here. This should be submitted. I don't want to develop an even bigger change here. This is new snapping code. This is just the header. This is again snapping. Signature change. Here I'm getting scale directly from the widget as opposed to this is safe because there is multi-threading involved. Should be fine. It's only used on the rendering thread. You can access widgets. Drag action was changed. Some comments that could possibly be removed. And this. This code is related to animation. I am keeping this. It can be commented. I will bring it back in the next change. Or new signature for snapping, like that. This is, again, snapping code is being changed. I'm not sure. Or a new way of creating objects. Let me see if this works. think instructions work fine. I can even grab a minimized instruction, for example, by the head of this guy. And it's snapping, but yeah, I'm holding it by the same point. So the transforms seem to be working okay. Some pieces of the code got simplified, picking the objects up. Or this, creating objects out of toolbar. Okay, this is again animation. This has to stay. This is important code. And velocity initialized to 0. And this we don't need. We can get rid of this function. Yeah, we have less data redundancy now. So not only animations handle more tougher cases, but we also don't need to repeatedly call this function to synchronize the data. We're wasting a little bit more memory, not much, a little bit. Yeah, nicer logging functions. I will submit them separately. Yeah, that was simplified a lot. Widget. This. Yeah, this is just snapping function. Okay. Changes that we have to do are located in those two files, in location CC and drag action. It's the optimization. Progressing slowly. Far from perfect. The fact that I'm using position and scale within location is also a little inconsistent. Maybe I should also use just matrix here. Matrix is everywhere. This location transform is more of a target location transform. Okay, I think I don't need this at all. Because the new code, which does the snapping with a matrix, with a snap matrix, applies this matrix to all locations, and that was more of a workaround. It was something that only snapped one object and then moved all of the other objects that laid on top proportionally. We don't need that. Alt position and alt scale are not used, so we also don't need that. I see. So if the object moved on screen and I'm taking this movement and I am directly moving the animated object here. Yeah, this avoids any delay, any animation delay. Comment would probably be nice here. So this is not really necessary to get animations. Animations will need to happen here within the location CC. Actually wonder why Git status doesn't say anything here. Like a bug in cursor. I need to decompose this matrix. Pivot is probably not necessary. Oh, it is. I remember, this is the hardest place. So this is our target transform. We can compute this matrix, it works nicely, but we want to decompose it into multiple matrices. So going from the right, translate minus pivot. Let me log some things. Okay, this is definitely global. This actually looks differently. How am I doing this? I'm using those initial positions. The problem is that this scale pivot, this is a global pivot. Position, scale. different ways of expressing the same.
CP Chica says,
Love to see Logan in comments.
What do you mean? I was looking around, thinking, what comments? We'll let it optimize some more. I think it can get below 120.
Wait, T energy. Am I thinking of right thing?
Ah, yeah. I love it. It's I haven't seen this. It's a handheld keyboard, and it was prototyped using this approach that I mentioned a couple of streams back, where I used the modeling clay instead of a 3D printer to make it fit nicely. So basically there is a board here. Deep inside you can see the MCU here, and it's literally wrapped in modeling clay, which was baked with it. Datasheet says it should make it up to 85 degrees, but from experience it can endure more. maybe the clock breaks in higher temperatures, but it definitely still works. Definitely the damage is not persistent. It's my new favorite way of making hardware. No more designing this in Blender and then converting this to STL and then trying to machine this out of aluminum. A nice tab. So this is a handheld keyboard, but the battery that it has, this is 10 times as large as the usual batteries that are used in keyboards. Normally people pack 400 milliamp hours, and this is 3500. I can basically keep this at full frequency, both cores active, Bluetooth connection active all the time, busy loop, checking the GPIO on keyboard pins, and the battery is still holding. It's amazing what a single cell can provide if you don't care about, making the battery small. The battery is the largest component of this thing.
Yeah, sounds fun. Too bad I have ordered custom PCBs for my keyboard, which are expensive to put in oven.
The nice thing is that this temperature is this is below the solder melting point, so it doesn't damage the solder at all. If there is some chemistry on the board, then that could be damaged by, but I don't know. Battery, obviously. Battery don't put in the oven. Everything else is fine. Page has a nice shortcut. Slowly creeping there.
You could missile-in contact point for low-profile mechanical switches.
I'm not proud of the way I connected everything. Basically, all the connections within this keyboard, they are structural. Like the keyboard switches, they are basically held by the wires that they are soldered to, and everything is wrapped in modeling clay. Yeah. The only PCB is the PCB from the development board. It's not the way you usually assemble electronics. There is this approach of doing, you know, those spaghetti type connections where you have loose wires coming everywhere. But here, the wires, they are not loose. They are actually high diameter, thick copper wires. The ground, the connection that I'm using for ground, this is 4.5 millimeter squared area, cross section. It's like this type of wire, it doesn't even fit in the hole in the PCB. This is like meant for actual house power. So all of the copper inside is actually meant to hold it together. Millimeter squared. That was the thickest wire I could get at the hardware store. One to two. We're getting closer. 2 for 1. I really like those final stages of the ant colony optimization because you can really see that this algorithm performs the global search and then switches to local fine-tuning kind of naturally. It does it by itself. There is no manual schedule or anything. Most frequent English letters. We have E. E. Do I have T? I don't. A. U. I is here. N is here. S is H. Yeah. Sounds like a good place for H. Do I have R? I do. It's here, okay. D is here. L. The L is there. C. U. U, there is no U. One. Very good place. Next is M. The keyboard is fairly certain that M should be here. I mean the keyboard, the optimizer. So designing a layout for a corded keyboard is totally different than designing a keyboard for a normal keyboard. Because on normal keyboard, you activate a key when you press it down. So this is what you're interested in. On a corded keyboard, you activate a key when you activate a chord when you release one of the keys. And the thing is, you can still hold other fingers, and it's actually very nice doing this, because it increases the stability of the keyboard in hand. It's more pleasant to use if you are holding more fingers. And then only some fingers can be moved to the next chord and pressed. So the search algorithm is a little bit more complex than you would normally use. Looks good. U 101 and M 110. I don't like the positions where something like this is pressed. A very uncomfortable position. Still above 120. Next is W. It's not bad. Maybe I should work on number cell. We should assign numbers. Or maybe I should trust the optimizer. It would be nice to have a mnemonic, like easy to remember positions, combinations for digits. I still don't have enter assigned. Huh. So 9 is used for parentheses. Very important key. I would like to exclude some. I'm not sure if this will work, but it shouldn't be printable characters anyway. Yeah, I don't want those cards to be used for anything. Let's fire up the optimizer again. Restart. It got to 120 milliseconds. One of those characters was an bell. It was system bell. Okay, so we have fewer chords to work with now, and the keyboard should use those decent chords. The layouts are already, I mean, not that bad. 143 for iteration. The stuff that we have coded here is already working. But okay, I will have to leave it for like half an hour so that it can finish. And in the meantime, I need to figure out how to do this matrix decomposition in AUTOMAT. So I actually do not know the local pivot. I could take this transform, invert it, get the global pivot and map it through it.
Effect.
The nice thing with matrices is that you can decompose them in whatever way you want and apply some transform on this decomposed representation, and then reassemble the matrix, and different systems can talk using matrices, using language of geometry, kind of like that. It's actually not local pivot, this is global pivot. This is local. So, two ways I can do this. I can play mathematician, expand those matrices. They are very simple. And find the formula for local pivot. I think I will do this. I will play mathematician. I will use AI with this. I think DeepSeek is very good at math, so I will ask it to derive me the formulas for this. First I will do a short break, so I'll be right back. Okay, so I'm back. Yep. And the optimization is going super slow. And the characters which are being found are those are very hard to type chords. I don't like them. Those. I need to open DeepSeek. And let's give it our job. I would like you to derive a formula or local pivot. You are given TT and in the meantime, it will think for a while. We could take a look at some of the topics some of the leads that I found during live, like Morphic. There we go. Self is a... I remember Self. It's an old one. Very small talkie. At least the syntax. Let me look for some videos on Morphic. And when I'm looking for lectures, I'm doing this off screen. There is a lot of morphic resonance. I'm not interested in resonance, or minerals, or geology. Maybe morphic Andy Smith. There is this. This is a port of Morphic to Squeak, I think, because it uses Faro. Okay, this could be interesting. Or this. Yeah, we have some videos. But they are all using the small tag version of Morphic. Introducing the Morphic designer. Okay. Those look like pieces of a curse, like a university curse. We'll silence the audio. Let's take a look at this.
Today we'll quickly do something with Morphic with Faro.
I could make this louder, but okay, I will. I'm a little bit afraid it can become very loud very quickly.
Okay, so we create this new object, it looks like. So let's say, I did Control D there, you see I created this. Now, we can run this delete command, and I'll delete it. I guess I haven't quite figured out yet how to okay, well, whatever. I thought that was kind of cool. Okay, I hope you enjoyed that.
Yeah, it actually was cool. The one thing that was, I think it was hard back in the day, was good discoverability for the methods, not those on-screen objects exposed. This is a Smalltalk VM, and Smalltalk VMs are insane things. They are more like browsers, like web browsers, except they don't care about internet. They are just local sandboxes for objects to play with other objects. Let's check out this. This looks like some part of a workshop.
Hi everybody.
Sorry for that.
Today I'm going to show you a little introduction to Morphic. Morphic is the default graphical user interface for several Smalltalks, in particular for quiz and squeak. I'm going to use quiz here because quiz is putting a lot of effort into improving Morphic, so we will keep quiz as a reference for the moment. Morphic is a graphical user interface for Smalltalk, but is something completely different from other user interfaces you have seen in other programming languages, and I'm going to show you why this is true. So let's see an example. Let's open a workspace. Let's open a transcript. Okay, keep it there, clear it. Okay, I've prepared a few comments to give here, so you don't need to wait me typing. Okay, so what you usually do in a programming language like Python or Ruby or something else, which is a rapid development tool, you can just run command line one after another and see something appear on your screen. For example, here I'm creating a new widget, W1. I do Ctrl D to run the line, Ctrl P to print the output. W1 class is a widget morphed. Okay, so let's open it into the world, that is this blue area, Ctrl D, and you see we have our small little rectangle that could be the main window for our application. Okay, let me ask print the morph position, is this one. I move it a bit to 200, 200.
Cool thing. World. This is a good name for the environment where objects exist. It's nicely connected to game design because in games you have worlds. Yeah, in online games, VR chat. Yeah, you connect to worlds, you switch worlds. And yeah, I think it plays really nicely. That should be fairly intuitive. That's a good term. It's like finding a treasure, like a well-named but difficult concept in programming.
Ctrl D. Okay, I can move it. You see, you create and you move it interactively, as you could do, for example, in Python NTK. Not in all GUI already is this possible, but it is possible to do in other programming languages. So let's go on. Extend 5040, so I want to make it a little bit larger. Ctrl D, and let's change the color, for example, to gray. Okay, I can also delete it. So if I go here, run this line, W1 delete. Okay, all done, deleted. So I reselect all this stuff and do Ctrl D so that I have back my gray widget. Now I want to add a label to these windows. This is still a classic graphical user interface, labels, buttons, and some kind of images, for example. So let's create the label morph. Ctrl D, Ctrl P, label, it's a label morph. So in this case, instead of opening into the world, I open it into the gray window because this label morph is intended to be inside the gray window, the gray window. Okay, Ctrl D, and here it is. We have our super basic graphical user interface. It's just a window with a string inside it. Okay. Well, this is what we always do from the programmer perspective. Okay, so we give command line and we see things appearing on the screen. But for the user, the life is completely different. The user doesn't know all this command line for sure. The user would do in a completely different way to do the same thing, and it is possible to do it in Morphic and Smalltalk. So look, I will go to do the exact same thing. New morph. I look the morph by name. Widget, new widget morph.
Stop. Interesting stuff is happening there. So we have a menu And notice what happens when he goes into a category. Like those categories, they are semantically organized, into things that make sense.
Morph by name.
But within a category, you still have, or this alphabetical list, you still have tons of morphs to choose from. So they are actually divided into some number of alphabetically sorted. Okay, this is alphabetical list. This is why they are sorted. This is a cool approach at managing the number of objects. If you are designing an object-oriented environment, the number of objects quickly explodes. In AUTOMAT, this is already in the hundreds. They are hidden. You don't see them. That's why you only see a couple in the toolbar. But instructions, we have maybe even 1,000, maybe even more than 1,000 instructions already in AUTOMAT. And they are held in this instruction library, which is a very compact way of choosing one of the hundreds of them. The mouse, the whole point of this mouse object that we have is that it's a place where we can hide many mouse-related objects, because otherwise they will just take all the space in the toolbar. Alphabetic index is a nice idea. Very nice to have something like that. One thing though is that in AUTOMAT I don't really have I don't really want to have a notion of, I have it, but I want to remove it if possible, of objects which are created out of nothing. I only want to clone object. I want to have something like prototypes. AUTOMAT has a list of prototypes that you can then clone. And from those objects you can access other objects which are sometimes hidden.
Widget, new widget morph. Okay.
Related objects.
Then I center click. These are called halos. And
I remember this. Yes. This was actually, I remember Morphic from my university time. Yeah. This is actually one of the things that probably inspired AUTOMAT to some degree. It's a very nice thing to finally find this environment. Within Smalltalk VM, you get access to those interactive objects that you can edit directly. It's like content editable HTML, except Smalltalk VM encourages you to use the Smalltalk language to program the environment. Yeah, I remember this. This is one of the things that I think influenced me when I was at the university a lot. This environment. One thing which is really painful in this environment is that it's using the Smalltalk language. Smalltalk language is fine. Actually, it's decent language, but it's another language that you have to learn to use this environment. So it's a barrier for anybody who wants to use it. And if there is a reason not to use a piece of software, it's not going to be used. So switching from Smalltalk even to a different language like JavaScript or something popular, that would open this up so much.
On the yellow one, change size. Okay, I make it large like this. Then I want to add a label, for example. So again, I do right click, new morph. This time is called label morph. So I go to look for it, label morph. Good. Now there is a problem. Label morph is independent from this other orange widget morph. Okay, so I put it here. Then center click, the blue halo, embed into widget morph. That's it. It's one inside another. They are ready. So we have done the same exact thing, either from a programmer perspective or from a user perspective, without knowing any commands, just clicking here and there. Okay, this is very useful. But the two worlds actually are linked. They are not separated. And let's see how these two worlds meet. I go into this widget which I created as a user, and you see here there is a reference to it, what we would call in C a pointer, if you want. So the French, copy to clipboard, and then I say that widget graphical or user made one. To make that nice arrow is I push an underscore key. Okay. Control D. VG1.
Naming is hard. I know this. That's why the environment assigns a random large number, name of the morph. This is very likely an address in memory. It's my guess. I'm not sure, but given that this is a VM, it could be an address. One thing is that in AUTOMAT we also had this problem. And when serializing the state of a machine, we have to name the objects somehow. So we name the objects the same as the type of the object plus a number. So macro recorder 1, macro recorder 2, and so on. Another strategy is to use UUIDs, which are totally scary to people who look at them. Or you have to use some random dictionary names. I've also seen that. That's a fun approach. You could try that in AUTOMAT, actually. This is a little bit confusing, these random dictionary words. It combines random adjective, random verb into a random name with a higher entropy. Anyway.
One class, that's a widget morph, and look, I can do the same thing I was doing before. I can manipulate it as a programmer. So for example, color is color green. Okay, very good. But we can do also a step farther than this, because okay, we can manipulate it from there, from the workspace, we call it here, but the point is, how can I know all the things that I can do with this widget object or with the label? So there are two things that make this system special, that everything is an object and always inspectable. So look this, you can do those things, two things. Branch allo, you can say, for example, browse morph class, and here is our browser for all the classes. So it tells us that, look, this is a widget morph, widget morph. These are all messages that are understood by these objects. So for example, color, but they are not all here, because this is a subclass of movable morph, which is a subclass of morph, and so on and so on and so on.
This representation is problematic. It's very formal. It uses the notion of objects and inheritance, and it even uses message passing, which is an abstraction that we made up to simplify programming, but sometimes it makes it more complex. Like, especially encapsulation, when you hide the information, like the color, the size of the object within the object, everything has to be exposed through functions. It's elegant on paper. In practice, it's awfully complex, inefficient. It's needlessly complex just. I think the description of widget morph, the stuff that you can see here, this could look better. The internal structure of widget morph shouldn't be a list of formal elements, functions like that. There should be some more interesting thing when you open morph like that. I mean, this is an inspector, but still. The internal structure of the morph. It's neither accurate, it doesn't describe like the reality, the hardware, like there is some memory layout there. It's not apparent from those properties or those functions. It's very abstract in the air. And from the human perspective, it's also, it's somewhere in between. It's very formally rigid.
Okay, so here you have an idea of everything you can do with this object. But let's forget this way for a while. There is another powerful thing, the inspector. Look, inspect morph. So you see here we have color. Oh look, there are this nice feature like border width is 2, border color is that will be a gray. So let's see that here to say that I want to send a message to this object that I'm inspecting right now. I say that self border width tab for autocompletion, tab width, I want it to be 5, let's say. Okay, then look, self border color, again I want it to be, for example, color red. And look, you see, it's really beautiful because you can inspect an object and see all of its characteristics and change them from the inspector. This is really beautiful. But until here, you may think, okay, I know other systems that more or less let me do something similar. For example, think of FreeCAD. FreeCAD is a program, software for 3D designing, and you can draw line, planes, manifolds. You can draw them as a user, so with a mouse.
Short pause because I want to see how the optimization is going. It's going terribly. Apparently those aliases that I forbidden, they have been useful. Let's look at some key assignments. 7 got assigned to here, 1, 2. Okay, that's strange. Dot and comma are there. The optimizer that I'm using, it assigns multiple chords to the same letter, but only during the planning. When I pick one chord, it's just one at this point. It's no more fiddling. For now we have for 9, we have now 2020. This is a nice assignment for square brackets. I like it. Yeah, now I like it even more. This should be 0. I mean 9. I think with those yeah, 0 to 1 is very symmetric. Yeah, so this makes all parentheses very fast to type, and yeah. Okay, so those are 4 chords that I just added. I will restart the optimization from the beginning. Go. I need to find reasonable places for those numbers. Oh crap, I accidentally assigned a new line here. And tab. Okay. Actually, escape. I need escape. Yeah, when I figure out where to put enter, I will put escape. Seeing let's open paren, close paren. The optimization now is very fast. It's like 100 iterations, it's already at 130. but it doesn't reach those crazy levels of below 120 milliseconds. I was testing the key pressing simulator, the one which presses the keys, and it's crazy smart. I mean, when it has several alternative chords to select from, it selects the one with the least cost to press, which is usually like releasing the thumb. Yeah, the optimizer is it's more clever than me. Nice combination. 1 2 2 1. This matrix is interesting because the algorithm is not sure of almost anything except this chord 2011, which is either going to be comma, I think, or minus, or okay, let's go back to morphic. Actually, no. Maybe you can push this. Let's see if this works. Should be RC function, yeah, there is RC. Okay, this part of the formula is problematic. Yeah, it's dividing by 0. Oh, is this nonsense? Maybe instead of target transform, we should use the current transform. Okay, when I initialize this, using this as a position, Oh. This map doesn't make sense. Maybe instead of using target transform, should use current scale and I think I could speed this. Actually, maybe this is okay. The way I'm solving those problems, just like swapping position of everything and reordering stuff, changing signs until it works. The local pivot is wrong, definitely. It's stable. Maybe I'm subtracting wrong things. I'm removing fancy math. I'm just using matrix invert. I'm not sure if I should use this or maybe this. One of them. I will have to try both of them to see which one works. Let's go for this one. This creates a better data flow without cycles. I am taking the current transform I should retranslate it by something like this.
Chandu16 says,
Hi, how is it going?
Hey. Slowly. Slowly, but moving forward.
Did you play with CUDA?
I used to. Actually, a very specific type of CUDA. NVIDIA, when it releases CUDA, they also release a bunch of functions for doing simple, very standard, maybe not simple, but very standard neural networks. And they have CUDNN. Yeah, that was the library that I used a lot. It makes basically neural networks like 40 times faster than without this library. And 40 times is a lot. At this point, I think I should animate the scale target scale. This get scale X is just I will use exponential approach. Maybe say 1 second. So objects will not move now. They will only be scaled. But they should be scaled around the place where I touch them with mouse. I don't know what to do. Maybe I will ask AI. Maybe AI knows better than me. DeepSeek is apparently good at math. Let's try this. Even describing this problem is hard. scale pivot point. It's unfortunately still scaling around the scaling around the origin. Another idea, yeah. Another idea that is pretty much guaranteed to work. Simpler approach to look at this problem. So I am grabbing the current transform, animating the scale. any of this. After changing the scale, I just need to make sure that local point is mapped to the same global position. Should be minus. It's going to be wrong. Anchor points. This is the only thing that in my head makes sense. And instead of using, apparently it wasn't correct, this one should be. I should also use local to parent here. Oh, I am. Okay, okay. I think it would be good. Yeah, I still need to animate the position. I'm using wrong animations, but objects should be animated now, I think. There will be a little bit of lag and the animations will be wrong. Other than that, it should work. Oh. Oh. What are you doing? I drop the object. Crazy things start happening. That should be fine. Probably no. To see if the issue will go away if I set it directly, the target position. don't understand this part. Maybe this scale fix is messing it up. Yeah. What is up with this? Transform color. Okay. Short break, be right back. I could use scale here. doesn't matter. Oh, I see, I see. I'm setting the whole matrix. I'm clearing like all of the fields in the matrix. This is what I should be doing. And now scale fix issue should go away. And I ideally should have nice, smooth object movement. Yeah, as you can see, oops, what happened to this guy? Okay, apparently there's still some issues. Let's look at the scale fix. Okay, initially global pivot should be set to 0, 0. So local pivot should have some value. Okay, I need to log those values to see what's happening. Yeah, local pivot. What? Okay, that was the issue. Reading uninitialized data, basically. Okay, so after scaling, I am missing this. Maybe I can do it again. So the current approach isn't actually that bad. Maybe I can fix it differently by doing scale fix afterwards. Definitely should happen here. Maybe I'm using the wrong transform. And let's reorder them again. Yeah, the bird is behaving strange right now. It's moving in a funny trajectory. Okay, I will have to think on this maybe in the background. All of this kind of makes sense. Okay, I have a working solution. Right? This works. This is fine. just want to keep this is another approach. I'm finding this local pivot and then I'm not sure if I should use post or pre-translate here. Maybe pre. Oh yeah, I'm using wrong target position here. See, there is no archy movement anymore. Now it's linear. And I am still able to hold it in place. Finally. Work here? Yes, it does. I can get rid of this solution, the one with anchor points. And maybe even I could simplify something. Deep seek wasn't necessary here. Although I don't like inverting matrices. Actually, I'm thinking maybe I could use post translate. use global pivot. And that should theoretically give the same results without inverses. And post-translate is also much simpler. Ah. Maybe sign is wrong. Actually, this breaks some of my assumptions for how matrices work. I guess global pivot is at a slightly different position in animation and in target transform. However, this should work okay. I see. I think I need to do something like this. Now it seems to work. This might not work. Who knows? Yeah. It has to be properly inverted. Why not? Let's make it vector. Okay, scale should be springy now. Or not. We'll go to infinity. Oh yeah, I need to save this velocity back. This is definitely not how it should look. Changing this to global will not make a difference. Or maybe it will. Yeah, it has to be minus position X. You know, retranslate wasn't that bad. And this is the target value. I still need to log them. It was looking so nice. I think the issue is that I am I should be using this contact point. I shouldn't be using global. Scale pivot. Yeah. This is the only place where this function is being used. And this is the place where we set it. And here it. I think it should be the local coordinate within the object's coordinate system. Yeah, and it should be only recorded when I press it. If I do this, I don't really need initial positions even. This may cause some issues, but this is the right thing to do. know why it doesn't help. That was a good change. Maybe I could do the fix trick here. Oh, there is a special function for this map origin. Nice. Maybe I forgot design. So origin fix is 0 here. I am removing the funny pouch. I'm hoping that Skia has a... Yeah, I can get rid of this. I'm just hoping that Skia has good enough math to solve this. Okay. Actually behaves nicely now. I don't need that. I don't need that. This is slowly getting simple, actually. Time to animate positions properly now. Try do this. I need to do something off screen, so I'll be right back. I am going to fix some more things around here, but I also have to eat something. So let's use this time and finish the Morphic video. Shut up the VLC.
and
Continue.
key combinations, but you can create and or modify them also with Python, with a Python API. So you can say, okay, even in FreeCAD, I can do the same thing basically because I can interact with the system as a user or as a programmer seamlessly. Okay, this is true, but the point here is that this thing is valid for the whole system, not only for what you are building. And let me convince you. Let's start changing this window that we are using to give commands, okay? So central click, let's inspect it. I go here, I see border color, for example, and I say, no, look, that self, cioè this object, border color, must be green. Whoa, see, your system changed, and you change it very fast and easily. But let's go on, let's change other stuff. Look this. I go here, and I say, for example, this is the class browser, okay? This is an important piece of the programming environment. Look, I go here, central click, I go navigate to the submorphs, clicking again, central clicks, I arrive here. Okay, look, I can say here just delete this, remove, kill this. Whoa, gone. I go here, central click, central click, central click, central click, central click again, and I pick it up. And that's it. I changed completely an important
This is what was.
part of
This is one of the things that were impressive to me when I first saw Smalltalk. Another nice thing is that it has this property similar to Hyperclay or WobbleWeb, where it serializes its state into a single file when it's saved, like all of the execution.
my programming environment. Now I ask you this, could you do this in FreeCAD? No, you couldn't. Because first of all, FreeCAD is made in C++. It uses the Qt GUI. So you would need to know, first of all, you need to know Python, C++, the Qt, graphical user interface, and also you would need to switch off the program, make changes, recompile, rerun it to see every little change you are going to do. So this is the amazing thing of this system.
So it's not entirely true. So many C++ classes, they have an ABI, so their memory layout is well defined. They have vtable with a stable arrangement of function pointers. So it is possible to replace code at runtime, also in C++, and to perform object-oriented manipulations in the same way. It's just, instead of existing within the VM of Smalltalk, C objects exist within the VM of the operating system. It's still a VM. It uses machine code as its native code, but it is virtualized. It can even be serialized like a Smalltalk VM. Core dump is exactly that.
It's really holistic. You can change whatever you can see, almost whatever you can see. And everything is here, and is here for you to inspect and to improve. So there is no limit basically to your creativity. What you can see can be changed. So I hope this is as mind-blowing for you as it is for me, because I never saw something like that before Smalltalk. Okay, that's all for today. See you next time. Goodbye.
Yeah. Full presentation. Morphic is cool. Okay, It was actually a very good introduction. I should probably.
The
give it a
user would do
plus.
in a completely different way.
It says part 1, that suggests there is part 2, but I'm not sure about that. Anyway, I think we saw what is morphic. Another thing which was recommended to me was eToys. eToys, please. eToys is it's another Smalltalk environment. This one is meant for, if I remember correctly, this one is made for kids. That looks nice.
Game Studio on how to make geometric shapes. Press the paintbrush icon on top bar. Press the big dot. Choose any color of your choice. Press keep. Drag. Alternate left click to bring up the halo.
Very cool, very cool. And you can see the resemblance. It's using the morphic UI environment. It's too bad that at the time when this all was created, this was the... Okay, maybe this wasn't the state of the art because the system interface looks nicer. It has gradients and imitates real plastic here. But it's probably not enough resources, like a compelling user interface, like visually appealing. We'll find another tutorial, because this one is probably meant for... Let's look at this one.
My name is Kathleen Harness, and this eToys project uses the motion of one object to control the motion of another object. I'm going to paint a blue dot, keep it, call it blue, and make a script for it that says blue, forward by 5, blue, turn by 5. I want to see the path that script takes. I make it true. I start the script.
This scripting language looks amazing. It is very readable. It is basically English. Yeah. This is nice. Yeah.
It's making a circle. I want to use that blue dot and that script to control the motion of another dot. So I'm going to erase that.
Blue is a pen. It leaves a pen trail behind it. So this is why this method clears all pens.
Trail. Paint a red dot. Name it. And the red dots script is going to be red's y is blue's y. And I can add these two tiles together. When I start these two scripts, add a pin trail for the red dot, true, and I'll match the color. So there's the blue circle, and here going to add one other tile to this project, and that is I want the red dot to move across the screen to the right. So I'm going to say red is X, increase by 10. I start the blue dot. I start the red dot. And we're making waves.
Nice.
Okay, and so, oops, where'd my project go? There it is. Okay, so this is the first tutorial. So the first thing you want to do is make a project. So go ahead and click on Make a Project, and you'll get this big blank screen to do whatever you like with. So we're going to do this in a couple different ways. I'm going to show you something, and then I'll ask you to do it, or sometimes we'll be doing things at the same time, and I'll let you know which is which. So right now, just watch, and then I'll give you a moment to do things. So what's up top is called the navigator bar. There's a bunch of different things up here. This is for saving and finding some of your projects.
Nice icons. They are not colorful, but the symbols are very clear.
But the most important thing right now is this little paint palette, which lets us create something. It brings up standard paint tools. And what we're going to do is we're going to draw a car as seen from above, just like that car we saw on the previous screen. And it's going to be pointing up. And there's a reason we want to do it exactly this way. And the other thing that I'm going to warn you of is that you don't make it pretty, because if I don't warn you of that, then you're going to spend a lot of time trying to draw a very nice card that you feel proud of, and we won't have time to talk about programming. So I'm purposely drawing.
Oh. The keyboard optimizer. It found a pretty nice matrix. I mean, nice. Not sure if it's nice, but let's see. I want to assign the digits. This is something that bothers me. So I have 0 and 9. It says that I should assign 1 in those positions. Okay, this is a good digit for a good place for 8. I like this one. It's very similar to 9. Oh, we went even below 120. For tab, it wants to assign 3102. It's not a bad character for tab. Stop this generation. Maybe this could be one. Oh. Impact the music. Testing the keyboard, see whether the key assignments make sense. With the exclamation mark. With the sign. This is going to be a hard keyboard to learn. I think I can simplify this if I assign more of the letters. I think then the algorithm will probably find better codes for digits. So G. B has this 111. Not sure about. Or maybe, yeah, maybe it's fine. 111 B. It's decent code for J. I see that there are some interesting similarities, for example, between P and B. It will make them easier to remember. Q. It's interesting that Q is located with 0. Oh. Where should I put W? This should be Y. And I assigned a lot of characters now, actually. Was there? B, yeah, from B to here. 8 new characters. I think this is enough. Should probably restart the optimization now. And the optimization right from the get-go has good results. 130. And it is just fine-tuning the remaining keys now. Ideally, I would like to have this property where the difference between one digit and the next one should be very small. Like, maybe I should even remove 1 from the map. I think I should. The optimization now finds good layouts so quickly. I have just 2 more letters to assign, W and X. A couple interpunction characters and a lot of digits.
An ugly car so that you don't need to feel that yours is the worst one in the room. Okay, so here's my car, and you can see that's its forward direction is pointing up. I'm going to fill it with some kind of color using the paint bucket tool, because if I don't fill it, then the car really is just that outline of the car, and when I try to click on it later, if I click in the middle, I won't be clicking on it because it's hollow. And so I want to make sure to fill it because that makes things easier. And then I'm going to create, by choosing black, I'm going to create a couple of wheels, maybe actually not a couple, but 4. And I'm going to use the paint tool, and I can choose different brush sizes. And you can see how large they're going to be. And so I'm going to put 1, 2, 3, 4 tires. And then I'm going to keep it. Oh, I need headlights. Good, so don't do this. But before I quit, I'm going to give it some kind of headlights or something so that I know where the front of it is and where the end is. So I'll give it these 2 little lights. That's kind of cute. Okay. Yeah, I tried to do something ugly and I think I failed. Okay. Good. So is that... So go ahead and do that, and don't draw something that's too pretty. Okay, so now we've got a car. So if you can just focus your attention up here. So notice I can pick up the car and move it around. And you can see it gives a little shadow to show that it's a separate object from the background. It's not, a painted thing on the background. And if you right-click or if you're on a Mac, Command click, or if you're not on a Mac, you can also Control click, Alt click, Command click, or right click. You'll get this halo. This is called a halo of little icons, or also called handles, which surround your object. And each of these does something. And you can tell what things do by just hovering your mouse over one of the icons, and some balloon help will show up. And you'll find that eToys is quite nice in giving you balloon help for just about everything. So, for example, this icon at the lower right will let me change the size of it. I can make it, fat. I can make it skinny. I can make it tall or short. If you want to keep the proportions and change the size, you hold down Shift while you do that, and it'll keep the proportions. Okay. And there's other icons which we may learn about. You could create a copy by clicking on this green one, and now I've got a copy. You could destroy the object by clicking on X, and so I'm going to destroy my copy. And
yeah, we really should add copying to AUTOMAT. It's something so simple.
Open up my trash can, you'll see
The infrastructure for this is already there.
But I'm going to leave it in there. If I want to empty the trash can, I can do that. So now it's really gone. And if I don't want my trash can, I can bring up its halo, and I can click on the little X. And now it's gone. It was thrown in the trash. Which trash? I don't know. Okay. All right. So the most important icon around in the halo is this blue, this aqua icon with the eyeball. So go ahead and click on that. And something like this opens up, and this is called a viewer. This is a viewer for the object, and tells us important information about our object. One thing it shows is its name up at the top, and notice it's called Sketch. Also, when we had the halo showing, the name was at the bottom, and it's called Sketch. And the first thing I'm going to do, and I want this to be a habit of everybody, is to rename your objects something that makes sense, rather than leaving them as Sketch, Sketch 1, Sketch 2.
Actually, this mechanism, which is called halo in eToys, is a little similar to the idea of flyers in AUTOMAT. They are not implemented yet, but the idea is that some objects, they are meant just as a nexus for options, so that when you hover over the object should show you all of the possible options around it. Kind of. Yeah, and they will look like flyers, like ads, like the paper leaflets that you can get on the street. But they will be arranged around the object, just like that.
To Sketch 3, because otherwise you'll find that you've got a program that says when Sketch 3 does this with Sketch 2's variable y3, execute script script 7, and you have no idea what it's doing. And if I see that and I'm trying to help you, I'll just throw up my hands and go, huh? So let's call it car, or something other than something that makes sense. You could type it over here at the bottom of the car in the halo, or you could type it up here at the top of the viewer. Okay. So these things in the viewer window are called tiles. And notice there's a tile that says cars X, and there's one that says cars Y. And as you pick up the car and move it around, notice how those change. So any guesses as to what those might do? So yes, those are the car's X and Y coordinates. And where is 0, 0? Okay, so yes, it's at the bottom left. And you can tell that because you see the numbers go down as I head to the bottom left. I can change these numbers in a couple of ways. Well, 3 ways. I could simply click on one of the numbers, and suppose I want my car's X to be.
Another nice trick. When he hovers over the number, the buttons for changing the number, they grow. That's nice.
100, I would just type 100, and I have to hit return or the enter key. If it's red, it means I haven't done that. Okay, and so now
It's also a cool idea. This is one of the problems with kind of real-time kind of text input and real-time changes, that quite often you, as you are inputting a new value, the intermediate value doesn't make sense. So the car would jump around as you are typing. Not what you want. Still optimizing.
it's at 100.
Actually, we'll try to push AUTOMAT a little bit more. I don't have much time today, so I will be ending the stream in 10 minutes. But before this happens, I would like to maybe improve this bit a little. So one thing is I would like to remove this scale pivot from here and maybe move it into the location proper. This animation state is totally unnecessary now. Change the scale pivot here and here. And that should still work. That was 1/2 of the change I wanted to make. The second half is meant to make this monstrosity a little more compact. Hey, that's like at least 2 months we haven't seen each other. Yeah. Man, it's kind of late. I will be running in 5 minutes, but before. So, what are you doing? Still making music? This is first time I hear of Tekken story. I guess there is some story to Tekken. I always thought it's just a random fighting game. Is there a movie? I think I should play a game like that. Yeah. Not for the story, but the mechanics are totally different than most stuff that I usually play. I usually play like sandbox simulators. Okay. Another thing I want to change is this and plus it. What's that? I will keep this as a matrix. So, for Silksong and Hollow Knight, I did play this. I actually was discussing this yesterday with my friends, and they told me that Hollow Knight, I always thought Hollow Knight is Souls-like. They had some decent arguments that it's actually more of a roguelite, because each time you die, you kind of get the opportunity to get more cash and upgrade your character. So a lot of the power spikes, they don't come from getting better at playing the game, but from just accumulating resources. Maybe lot is the wrong word, but a big chunk of power spike comes from just accumulating stuff. Okay, and this is time for me. Yeah, this mechanic of getting your corpse back, that was another thing that made it more like Dark Souls. Yeah, but I realized it's just not my type of game. I can play this, that's fine, but it's kind of frustrating. You run, you find a new boss, and you basically have to spend, I don't know, half an hour learning the patterns of the new boss, because it's designed to be punishing, confusing, very jumpy. Yeah. Okay, I got to go. See you next time, I guess. Yeah. Bye bye.